In our previous video, we installed Linux on two partitions, one in particular being the root partition, which contained everything that we needed, and a swap partition, which is an overfill for any memory when we need to be able to use more memory than required. In this video, what we'll do is to look at a little bit more resilience for our system and partition up the disk so that we can put things in separate places. For example, our home directory where all of our files would be contained. If we were to upgrade our operating system or even decide to change the version of Linux that we wanted to run, we want to keep our home directory in place so that we don't have to go through the rigmarole of copying our data back on or backing it back up again. Or alternatively, we might want to back up our data and have to only restore that part if we had a major issue with part of the disk or we lost a major part of the file system. So when we look at file systems, the file systems are what contain all our files and keep them in a structured order. But underneath the file system, the disk is separated into specific parts. When we did the installation in the last video, we had two partitions, and we used HDA1 or HDA2 or SDA1, SDA2. We'll talk more about those shortly. But in the diagram you can see here, what we're looking at is the fact that certain parts of the directory structure that Linux is famous for, and taking that from Unix, is that our root file system comes from one particular part of the disk, but we can take specific directories. In our example here, USR is on a separate part of the disk, or in fact if we've got more than one disk, we can put things on different disks, making our system even more reliable. And in some cases we can use partitioning to speed up the way in which we can access disks. So our view of the file system here shows us the root, and within the root we need directories that we can then hang other file systems onto. So USR would have a directory in the root file system in dev HDA1, but then we take HDA2 and put it on top of USR. The ones that are highlighted and circled on this diagram are ones that are common to all versions of Linux and Unix, in fact, and we can actually create mount points and file systems for those particular directories. Linux supports many different file systems. We listed just a few here. The particular ones that you'll be interested in, VFAT, for example, if you've got Windows file systems, or even NTFS for good versions of Linux. Fedora supports read-write version of NTS, and most Linux systems support read-only versions of NTFS as well now. We've got the CD-ROM file system, the ISO 9660, and we've got many iterations of the Linux file system, ext2, 3, and 4. As well as having a riser file system. You can look those up online, go to Wikipedia, various places will actually tell you what these different ones are, and they all have their advantages depending on what you actually want to do. The disk partitioning name convention with Linux, normally everything lives in /dev, but in particular if you've got older IDE style disks, you'll find that your disks are named /dev/hd something. The A represents the first disk, B would be the next disk, and then the 1 would be the slice of the disk or the partition that we're actually interested in. So in our previous slides, if we go back, /dev/hda1, that's the first partition on the disk, HDA2, second partition. The diagram here is very basic, and I'm not going to go into too much detail about how partitioning works. There's many other places you can look at for those. If you're using SATA disks or even a SCSI interface, then you'll find that your disks are /dev/sd something, so SDA3 would be the third partition on the disk, and so on. Pretty much almost everything can be partitioned. The key things that can't be partitioned is that within root we must have etc being part of the root file system. sbin must also be part of the root file system because that's where our system admin binaries are, and these are the binaries that keep the system running. /dev because the system creates that when it boots. /proc is a memory-based file system anyway, and the kernel creates that on boot. And mnt because mnt is a temporary temporary mount place that allows us to mount other file systems if need be. Disk space considerations then. When we're looking at what we're planning on separating out, we've got things such as the root file system generally has slow growth, because if we separate out enough file systems, then we don't need to actually do anything in root apart from if we're adding things into etc, so configuration files would change. /USR will grow every time we install a new application because that's where the binary programs and libraries go that make up the program. /var is a variable sized, and that's one of the most difficult ones to work out how big it needs to be. In var, so for a home use, you'd be looking at things maybe about email if you're planning on downloading your email there, but more particularly printing and the log files will be your biggest issue with that, so you'd need to keep those clean. /home, that's obviously going to be down to you and how much data you're going to use. /temp ideally needs to be big enough. One of the biggest problems with /temp, if you don't make it big enough and you're running a GUI, you'll actually stop the GUI from running and you'll end up with things like blank screens occurring. And if you're planning on installing third-party software, then /opt may well be another directory that you'll want to separate out onto a different disk. Now let's take a look at the commands that we can use to find out how big our partition should be based on some directories that we want to change and make partitions. A couple of commands that we can use to start with to see how our current system is configured. First off would be df. df means disk free. The -h allows me to get back human readable information, so things will be in gigabytes and kilobytes rather than just big numbers. What we can see from our output here is that our root file system lives on /dev/sda2 currently. That's the second partition in the disk, and back in our previous video we said that we wanted two partitions, one for root and one for the swap space. So this currently contains everything for our system. The others for the moment we can ignore. They are what we call memory resident file systems. They are created by the kernel when the system boots up. Another useful command for finding out how our system is configured is fdisk. Now I'm putting the word sudo in front because I need to elevate my privilege to being an administrative user to run this command to see how the disk is configured. That runs and should ask me, or may ask me for a password depending on whether I've already run the command or not previously. And what we can see from here is that we have our two partitions on the disk, SDA1, which is our swap file system, and SDA2, which is the one that contains our Linux installation and all the files to do with our operating system at the moment. If we had more disks in there, we would be shown those as well, and we would see how they were partitioned out as well. These system labels that we have down here, hopefully when people partition up their disk they put the right system label on there to give us an idea as to what type of file system is going to be put on that disk. Another command that will be useful, now that we know how our file system is laid out, is to be able to find out how big certain directories currently are that we've installed. So if this was the first time that you'd installed Linux and you hadn't installed all of the applications that you wanted to, you would then go off and install those applications. That we'll show you in another video. But for this, what we want to do is we've sort of assuming at the moment that we've installed all the apps that we want, and now what we want to do is to get a summary of the size of directories that we're interested in partitioning out. So let's say we want to take a look at var, usr, home and boot. So we want to know the current sizes of those 4 directories, and hopefully from there we can then go back, do an installation and use these sizes to work out how big to make our file system. So again, I'm using sudo because there are certain files in each directory that will only have access to the super user of the system. So we run the command, it goes off, and it takes a little while for it to go and find the sizes, and as it finds the sizes, so you can see here it prints out the sizes. /var 820 meg. Now remember what I said earlier is var is a variable directory, so it's going to grow and shrink as log files change, as printing happens, and various other features like that. So we tend to sort of add 20-30% depending on what we think the use is going to be, so we might need to make it larger until we know how big the various files are going to be when we're creating them, and we need to obviously maintain that on a regular basis. The USR will be quite large. The reason behind that is that all of our operating system programs are installed in USR, and as we can see here, the final output is 3.7 gigabytes in /USR, so that one's going to be quite big. 13 meg for home because we haven't put anything into the user's home directory, so we need to consider how much data we're going to put into our own ones. In fact, in some cases, if this was your home system, what you would do is make that the largest part so that you can have all of your data in there unless you want to separate out your data into different directories. And then the boot 75 meg, that really is the boot kernel, and in most cases you probably want to allow for maybe 2 or 3 different kernels to be installed there. So at most you'd probably want /boot to be 1 gig. So from this, what we can sort of gauge is that we have a 20 gig disk, which we found from df-h. We've got a 20 gig partition in total, and out of that 20 gig we could say, well, USR, we might install some more software, so let's make USR let's say equal to we'd probably go for maybe 5 gig, okay, possibly a bit more. Let's make that 8 gig. Okay, we could then make the boot, as we said, only really needs to be 1 gig. That would store enough different kernels that we could go back if we needed to. And then given that /var currently is at 820 meg, we want to allow a bit of growth when the system starts to run. So we may decide to make that sort of 2, maybe 3 gig in size to be able to cope with what's going on at the moment, because it's nearly a gig already. Actually, let's make that 4 gig. And then the rest of it we can assign to the home directory. Okay, so at the moment we're looking at 13 gig there, which means our home directory can be 7 gig for everything that we want to put in our home for that system. So from now, what we can do is go back, do another reinstall, partition out our disks so that they're in separate locations, and have a system whereby we can, if necessary, recover our boot partition if that goes wrong, recover our applications in the user directory if that went wrong, or even back up our home and recover the home if all went drastically wrong. But it does mean now that if we go back and reinstall, we can get things in our home directory left as they are, so that every time we update the system we haven't got to keep putting our files back on when it goes wrong. To finish off this video then, we'll take a look at that repartitioning, and we've got to the point in the system install where we've selected the installation destination and we've popped up with the installation options. As we said, our installation scheme in this case wants to be standard partitioning, and we want to customize the partitioning. Now, because we already have an installation, we can see the installation here in our partitioning, and we want to delete this partition in particular and basically start again. So we'll click on the minus symbol and we'll delete that, and we'll reuse the swap space that we currently have. So we'll tell it to reformat as the swap, and we'll leave the swap as we did with the 200 meg. Update the settings, and now we wish to add, by clicking on the plus down here, our other file systems that we required. So we will have our boot, which is not showing on there. There it is, our boot, and the capacity we said for the boot was going to be about 1 gig. So we'll put 1000 in there because the dimensions are in megabytes, and we click on the add mount point. We then click on plus again, and this time we want to put in our /var. We said we were going to put 3 gig in for /var, so we can do that, but I've just remembered we didn't put into account when we were doing this our root file system, and we should have looked at the whole size of what the root file system was, which we could have done from the DF, and it told us how much was in use. The majority of that was the 3 sort of gig for the USR file system. So I'm going to put my var in at 2.5, and then we're going to add another partition. This time our mount point will be our USR. Okay, and for our USR we'll go for the 7 gig or 6.5 gig, 6500 for that. And all the time the system will keep a track of how big our file system is that we're after. Now, I haven't been changing anything over this side. The ext4 file systems are what's being used by all of these directories and partitions that I'm creating at the moment. So we're going to put another partition in, and we're left with /home. Now, technically, /home we should sort of leave until the last one, and we'll give /home the rest of the disk that's available to us. So we ought to put something in for the root file system, and technically the root file system, now that we've taken out USR and var, would be quite small. So what we'll do there is we'll make that 500 meg, just to give us enough to work with, and then finally we'll add /home, but this time we won't put anything into the drive capacity. or desired capacity, because what will happen now is it will fill in the rest of it for us. So it's given us 10 gig of disk space there available for /home as our data file system. So if we didn't want the 10 gig, because we actually said we only wanted 7, we could change this down to 7 gig and click update settings, and if necessary we could remove the root file system and then add the root file system back in, and in this case leave the desired capacity empty, and we get 3.276 gig, or like I say, we can keep adjusting these to make them suit so that we can allow USR to be bigger or root to be bigger. So like I say, we can take that one down to 2.5 gigabytes, update the settings there, and then come back to USR, remove USR, add it back in, stick in USR, and then add mount point, and we can see now that we've got 7 gig available for that, and so on. But we'll leave it at that one, and what we can do now is to continue to do the install, knowing that we've now got our partitions in place. We click on done, and that will tell us about destroying the formatting. We accept the changes, and then that goes back and tells us that we can now continue with the rest of our installation from this point onwards. So to sum up then, what we've been doing, we use partitions to deal with things such as system recovery, where we can recover just parts of the file system, or if we wanted to update our operating system, we don't need to blow away our data and recreate it or back it back up and then put it back on. We can get speed from using different disks or using different parts of the disk, so that helps with making things quicker for us. And security. In some cases you might want to encrypt a particular partition but not encrypt other parts. Certainly your boot partition you wouldn't want to encrypt, because we wouldn't be able to boot up the system itself, but you might want to encrypt your home directories. We made use of the du command to work out the size of the directories as well, and remembering that when we're using this command, the values that we're going to use to repartition our system may be bigger than are actually being shown. /var and /home come into mind when we're sort of dealing with that, because they will be very small when we've just installed the OS. So we should always allow growth on our partitions that we're working with, especially things like /usr, where new updates and new versions of software may actually be bigger because of new features that have been added to it. So always allow an element of growth. Don't actually fix them specifically exactly to the size that you've just measured. And finally, the standard partitions are always fixed. So once you've created those sizes and the file system's been applied to it, you can't grow them. Because as soon as we start moving partition boundaries, we impact on one of the other partitions that's already been created on the disk itself. But there's nothing stopping us adding a new disk and moving that entire partition to a bigger place on the disk and then growing the file system itself. Later on in the series, we will take a look at a thing called a logical volume manager that does allow us to dynamically grow file systems if need be. And also we'll take a look at partitioning again later in the series, so that we can start adding other disks and other partitions permanently to our system itself. So that concludes this video for partitioning and being able to sort of install your operating system again with partitions.